When it comes to insulating an old house or building, we can't just insulate the cavities and call it good. It's a lot more complicated than that, and insulating an old house haphazardly can often lead to its rapid degradation. Adding insulation to a previously uninsulated building completely changes the moisture balance, as the amount of heat flow is reduced, and so the building stays wetter for a longer period of time. With that being said, we're going to talk about the 5 dumbest mistakes that you can make when it comes to insulating an old building, and what you should be doing instead to make sure that you don't cause any future moisture problems. Let's get into it. Probably one of the worst mistakes that you could make when insulating an old house or building is blindly insulating the cavities with blown-in insulation. Oftentimes, blown-in insulation or injection foam is used as a minimally invasive method to insulate the walls of an existing building by cutting a small hole into the wall and filling the cavity with insulation. And this is a really appealing strategy to a lot of homeowners because it really minimizes the amount of potential drywall removal or demolition. But the problem with this method is that we can't actually verify what's happening inside the wall. And if there were small incidental leaks that went unnoticed because they were previously drying out unrestricted, we can run into a whole bunch of moisture problems since now we're reducing the drying potential of the assembly. We need to be able to visually inspect the backside of the wall sheathing for any water staining, mold growth, or any other evidence of moisture intrusion. We can also get the paint peeling off of our siding if we blindly insulate the wall cavities using this method. Why is that? Well, historically, siding was installed directly against the wall, over the tar paper, or sometimes even directly over the sheathing, without a drainage gap, so water would be absorbed by the siding, but it would dry out fairly quickly because there was a ton of heat flow in and out of the building. However, by insulating, that moisture stays in the siding for a longer period of time, which can cause the paint to blister off, especially if it's an oil-based or impermeable latex paint. And so if we want to insulate an old wall using this blind fill method because we want to avoid damaging any interior finishes, we need to address water management first on the outside, and that realistically means usually removing the existing siding, installing a new high-quality water control layer, ensuring that we have our proper flashings in place and that they're integrated into the water control layer to direct water away from the building and away from openings like windows, and then recladding the building with a small drainage gap. And that's really the key here, is to provide a drainage gap between the cladding and the water control layer to alleviate hydrostatic pressure and to make sure that water isn't held in tension against our building. If we reduce the drying potential with insulation, we have to reduce the wetting potential as well. We have another video on our channel called Sometimes It's Better Not to Insulate, which we'll link up here, and that video discusses the reasons why, if you can't address moisture management first, you should not insulate despite what many people will tell you, as this can do more harm than good. Just a quick reminder to hit that like button if you're finding this video helpful, and leave us a comment if you have any questions, and we'll try to answer it in the comments section below, or address it in a future video. This may come as a surprise to a lot of people, but we actually need to air seal our buildings if we're insulating them. Back in the day, the abundant amount of air leakage in an uninsulated home or building in combination with constant heat flow really helped to dry out the structure if it ever got wet. But after we started insulating our buildings and conditioning them, air leakage actually started to wet buildings, as air leakage condensation is a major driver of a lot of moisture issues in buildings nowadays. Air has the potential to carry an enormous amount of moisture in the form of vapor, and a 1 square inch hole in the air barrier with a small pressure differential can end up depositing the equivalent of up to 24 gallons of water over the course of a heating season in a cold climate. Think about it, if we've insulated the stud or rafter cavities, the backside of the sheathing is going to be colder because it's thermally isolated from the interior, and if we couple that with some interior air leakage, what's going to happen? We're going to get condensation, except now that condensation has a very difficult time drying out because of the insulation, which slows heat flow. The reverse can actually happen in hot, humid climates in which we're air conditioning the interior space, and we can get condensation on the backside of the drywall. So nowadays, if we're insulating an old building, we want to make sure that we're also air sealing the building assemblies from the outdoor environment, providing a means of drying through vapor diffusion and through some mechanical ventilation so that we can have a controlled interior environment. Remember, houses don't need to breathe, they need to dry. People need to breathe, and we need to bring in air on our own terms that's dehumidified and filtered in order to make sure that we aren't deteriorating our buildings. We have another video on our channel discussing the differences between air barriers and vapor barriers, which we'll link up here. If you're looking for a guide to retrofitting an existing home with insulation and improving energy performance without compromising durability, get my guide to moisture management for residential remodels, in which we discuss how to safely insulate and address a wide range of existing building conditions. That's only available at asiri-designs.com/shop. Now, back to the video. Building off of our previous two mistakes, we need a means of condensation control when we go to insulate an old building. Again, if we just insulate the cavities of a wall or a roof in a temperate or cold climate, we can run into a whole bunch of condensation issues because now the backside of the sheathing is colder, and so we either need to slow down the amount of moisture diffusing or leaking into the cavities, or we need to warm the condensing surface of the sheathing. In many cases, the best strategy is to insulate from the exterior with rigid insulation, as this will ensure that the backside of the sheathing is kept warmer, and that we can guarantee better moisture safety even if you are operating at a higher interior relative humidity. This strategy is really great if you can't address things from the interior side, or if you don't want to remove any of the interior finishes. It also protects the water control layer from damage, and so the assembly is going to last a lot longer. Now, if we can't address things from the outside, we can address our condensation control on the inside with closed-cell spray foam, as this provides the benefits of an air barrier, a vapor retarder, and it has a very high R value per inch, and it essentially encapsulates the backside of the sheathing. Now, there are some problems with this method, which we've discussed in previous videos. However, it is an option if you can guarantee a perfect install, but that's usually the problem. We can't. Now, whether you're using exterior rigid insulation or closed-cell spray foam, we need to follow these minimum condensation control ratios that are based on operating at 70 degrees Fahrenheit at 35% relative humidity, and these ratios are the basis for current building codes. Obviously, if you operate at a higher interior relative humidity, you need to bump up that ratio. We can also provide condensation control using a taped smart vapor retarder membrane in combination with our standard insulation batts like rock wool or fiberglass. And a smart vapor retarder membrane will provide the benefits of condensation control by slowing down the majority of outwardly driven vapor while allowing for drying back to the interior if conditions are wet. We've discussed this as a retrofit strategy at length in this video, which you can go and watch up here. Now, using the wrong type of insulation in the wrong location can also get you into a lot of trouble. Not all insulations are designed to be used in isolation for all climates. Remember what we talked about in terms of condensation control. Some insulations are vapor permeable and air permeable. Some insulations are air impermeable but vapor permeable. And some insulations are air impermeable and vapor impermeable. For example, we wouldn't want to use open cell spray foam in isolation in a cold climate, since open cell spray foam is vapor open, and we would need to apply a vapor retarder to that spray foam if we wanted to make that system work, or use closed cell spray foam or rigid insulation in combination with that open cell foam. Another example of this is using rigid foam insulation that's cut to fit between the studs or the rafters. This is called the cut and cobble method, and it's a very risky building practice as rigid foam is a vapor retarder, and so we're already reducing the drying potential of the cavity, but unlike spray foam, we can't reliably air seal around each stud or rafter, and so we often see condensation form because that rigid insulation isn't properly air sealed. We want our rigid foam products to be installed outboard of the sheathing and the air barrier for this reason, and we want to make sure that we're allowing our stud and our rafter cavities to be able to dry back to the interior unrestricted so that we aren't trapping moisture. Finally, one of the dumbest insulation mistakes that you can make is to specify foil-faced, plastic-faced, or vinyl-faced batt insulation within the cavities. Foil, polyethylene, and PVC are all Class 1 vapor retarders. We cannot dry through these materials, so if moisture gets into the cavity, it has no ability to dry back to the interior side, and that's really a big deal, especially in warmer climates where the majority of the drying occurs to the interior side because vapor drive is from the outside inwards. We know that moisture is going to get into that cavity at some point, whether it's through an air leak, vapor diffusion, incidental moisture, or a plumbing leak. Buildings dry via vapor diffusion, and if we're stopping the movement of vapor from the cavity inwards, we're going to get moisture accumulation and mold growth within the cavity. We see this all the time, even in colder climates, because we have something called seasons. We highly advocate for the use of unfaced batts since we can predictably dry through them, and if the building is able to dry out, we don't get any problems. If you found this video helpful, make sure to leave a like and subscribe for more weekly building science videos, and head over to our website at ASIRI-designs.com, where we have over 150 free building science articles that cover a wide range of topics. Links will be in the description below. For now, good luck with your projects. Cheers.